Well, good morning and welcome to NASA at 50's virtual birthday party. I'm Damon Talley coming to you live here from the Kennedy Space Center. And with me this morning, my special guest is a NASA engineer, Mr. Shirish Patel. Good morning, Shirish.
Good morning,
Thanks
Damon.
for coming out
You
this
bet.
morning.
Glad to be here.
Me too. Now, we have a very busy schedule this morning. I'd like to do an overview of what's going to happen. All 10 NASA centers are going to be connecting over the next 10 hours to international schools and U.S. schools to celebrate NASA's 50th birthday party. It's 9 a.m. us here at the Kennedy Space Center. The topic will be the Space Shuttle. 10 a.m. Eastern Time, Project Mercury from the Marshall Space Flight Center. 11 a.m. Eastern Time, the Viking project from the Langley Research Center.
Welcome to NASA Langley Research Center. I'm Bob Starr, manager of NASA's Digital Learning Network, and with me is Ed Pryor, who is going to be talking to us today and answering your questions about the Viking project. This is a very special day, actually a very special year for NASA. As you know, we're celebrating our 50th year, and we're so happy that you're connected with us today to help us enjoy this celebration. We're anxious to hear what you have to present to us. I'll introduce the schools in just a moment, but right now I would like to introduce you to Marcy Powell, who is president of the United States Distance Learning Association.
Thank you, Bob. Welcome, everyone. This is very much an exciting week, as it is the National Distance Learning Week for the United States. So there are all sorts of distance learning activities going on around the U.S., and it's exciting when we can bring in global partners and global schools from around the world.
But right now, what I'd like to do is meet the two schools that are connected with us. And I also would like to say that we are webcasting this, so we have probably a pretty large international audience watching this show right now around the world. Let's go to Rotherham, England, to the Newman School.
Hello there from Newman School. Can you see us? Can you hear us?
Yes, we certainly can. We can see you, and can you explain exactly where you are in Great Britain?
Rotherham is in South Yorkshire, and that is in North England.
Well, I noticed that you have a Viking there in your group.
We certainly do. We certainly do.
Hello, my name is Chris. I know I look a bit like Eric Bloodaxe, but seeing as though our topic was the Viking landings, I thought I'd dress the part.
And then we're going to come all the way back across the Atlantic Ocean to Norfolk, Virginia, and we have the School of International Studies at Meadowbrook. And Lisa, are you there with us and your students?
Yes, I'm here with the teacher, Mr. Paul Jones, and his class at the International Studies at Meadowbrook. This is Mr. Jones. Mr. Jones?
Hi, I'm Paul Jones. I'm a science teacher here at the School of International Studies at Meadowbrook. And my students and I have a little tribute to pay to you all a little later, celebrating your 50th anniversary.
Let me open it up to some questions. I'm looking at our school from the UK right now. Do you folks have any questions for Ed?
Do you think that we'll be able to live on Mars?
There's some people that think that someday we will be able to colonize it. I personally have my doubts that that'll ever happen. The planet is so very different from Earth.
In what way is Mars different to the Earth?
There's no magnetic field. So, for example, if you have a compass, which you need to get around on the Earth, it's totally useless on Mars.
Are there any other obstacles in colonizing Mars?
Ultraviolet radiation comes smashing in from the sun directly. There's no ozone to shield the ultraviolet radiation.
Could we ask you, what is the temperature range on Mars?
The temperature range that they found on the Viking 1 lander, it varied between minus 120 degrees Fahrenheit, which is terribly cold, to minus 20 degrees Fahrenheit.
What kind of weather is on Mars?
The polar regions are so cold that the mission that just shut down, that we were talking about earlier, the Phoenix mission, it just shut down about a week ago. And the reason for that, Phoenix landed in the northern polar region, and it's way, way colder up there. And they knew sooner or later the cold would kill off the instrumentation, and unfortunately it looks like that's what's happened.
Do you personally think we'll live on Mars?
I have my doubts that we'll ever see people living on Mars. But as I said, there are some folks out there that have a serious idea that someday we may be able to colonize it. That may be far in the future, though.
If you rule out Mars, are there any other planets in our solar system possible for colonization?
None of the, unfortunately, none of the planets, with the possible exception of Mars, are really have the type of environment that would be conducive to human life. They all have some problems. Jupiter, Saturn, Uranus, Neptune are really huge gas bags. They're basically gaseous planets.
And Mercury?
Mercury's out of the question. It's way too close to the sun. It would boil you on one side and freeze you on the other. Mercury keeps one face looking at the sun at all times, and that side is way too hot, and the other side is way too cold because it never gets sunlight.
What about Venus?
Venus is definitely not where you want to live. It's hot enough to melt lead. It's 900 degrees Fahrenheit on the surface, and the atmosphere there is about 100 times denser than our atmosphere, and it's all carbon dioxide. So really, we're very fortunate, I think, to be on the Earth. It is in exactly the right zone for humans. That's not to say there aren't possibilities of life.
Could life have evolved, but not based on H2O?
Titan is a very exciting place, even though that's not a planet. It's a moon of Saturn, but there's a liquid on it, liquid ethane. And it's possible that some strange type of life has evolved using ethane as its main liquid rather than water. We're all water-based here on Earth.
Is it true to say that some folk do believe there is life on Mars?
There are some other scientists who think there is evidence based on the Viking data. They're in the minority, though. What we concluded there, we didn't say that Mars was devoid of life. What we concluded was that, this is the basic conclusion of all the biologists that have really looked at the data, we cannot say for certain that we detected any life on Mars.
The Viking mission took 11 months to get to Mars. Could we get there any faster?
Good questions.
Well, if you have a powerful enough rocket, and one that you have a new kind of fuel that we don't know about yet, and you can travel really, really fast, you could shorten that length of time to get to Mars. But we're not there yet. The fuels that we have right now, the types of rocket fuel we have right now, to get to Mars from Earth, you really are looking at on the order of, I would say, 6 months to a year and a half. That's kind of the range.
What is the atmosphere like on Mars?
It's practically all carbon dioxide, but there's very little of it, and compared to the atmosphere on Earth. I mean, here we have the typical pressure is about 15 pounds per square inch. We're used to living at the bottom of this ocean of air and on the Earth, and it's 15 pounds per square inch of pressure on us, whereas on Mars, it's about 0.01 pounds per square inch. There's very, very little atmosphere on the planet.
You mentioned carbon dioxide. Are there any other gases on Mars?
Well, Viking discovered there was some nitrogen gas in the atmosphere. About 3% of the atmosphere is nitrogen. And we think that that's residual gas from the volcanic eruptions that used to be on Mars. Right now, all the volcanoes are quiet. But at one time in the past, we know that there were a lot of eruptions, and there was a lot of gas flung into the atmosphere, including nitrogen and other gases.
What about ozone?
Unfortunately, there's no ozone. Almost no ozone, virtually no ozone in the atmosphere of Mars. And of course that means that if an astronaut is on Mars, he has to worry about the sun because the ultraviolet radiation is coming right in on him, smashing in on him. There's no ozone filter at all.
Before we go, we'd just like to thank everyone for inviting us to talk to NASA on this celebration. We have to sign off now.
Thank you all for joining us today, and we wish you a great future in science, math, technology, and engineering. Goodbye.
Thank you.
Bye.
Thank you. Bye.